Thank you for attending robot webinar today. My name is Artur Kosakowski and I will be running today's presentation together with my colleague Rafał Gawenda. The topic of this webinar is the link between advanced steel and robot. In this presentation, we will demonstrate the interoperability among Autodesk structural design and steel fabrication programs and show various workflows you may want to adopt to increase your productivity. We are not going to focus on clash detection today, but this is what may happen when analytical and fabrication models are created with limited knowledge of their surroundings. At some stage of your project, you may suddenly discover that a column turns out to be in the middle of a transportation road or over an underground tunnel, or bracing is just where a main air duct is located or where an empty space for machinery assembly is required. The link allowing you to start your analytical modeling AutoCAD application where you can see all the obstacles may be just what you need to avoid such situation in the future. Wouldn't it be easier if you have all the information visible before you decide on the geometry of your steel structure? What if you define its geometry in Plant 3D, for example, with all the pipes and roads visible? Let me show what I mean. Okay, you can see now the plant model, the plant project with all the information needed. And we will also, during the course of this presentation, focus on the part of this project to demonstrate how to link plant model with robot. In this webinar, we'll focus on bidirectional model exchange between advanced steel and robot, as well as introduce the interoperability between Plant 3D and robot. We'll also look at the connection design in robot in advanced steel and show the way of adding advanced steel output to RSA documentation. In the next webinar, we'll get you familiar with vibration of floors and footfall analysis. The link allows for the exchange of structural framing elements, materials, and export of internal forces calculated in robot to advanced steel. You can import robot structural models to advanced steel to detail steel elements, automatically generate fabrication drawings, and verify connection types not available in robot. You can export advanced steel models, elements, sections, and materials to robot in order to perform structural analysis and code checking for elements of a model, as well as verify steel connections. The link allows for the exchange of structural Advanced Steel is a 3D modeling software for steel detailing, and you can get more information about this program or access its trial version under the link shown on this slide. Advanced Steel Robot Link is available for download from Autodesk App Store site for customers with valid subscription. Let me introduce the conceptual assumptions of the link first. The most important one we made at the link design stage was that each program is responsible for its own model type, to avoid a situation when modifications done in either of the program destroy already fine-tuned model in another one. Another tool where transfer of analytical lines from advanced steel to robot preserves information of the system line position defined in advanced steel, and keeping the attributes and loads defined in robot during transfer to advanced steel. What it means is change of analytical model of imported advanced steel model in robot cannot influence a fabrication model in advanced steel during the subsequent model synchronizations. Change of sections in advanced steel, which imposes movement of their system lines, cannot destroy already corrected calculation model in robot during subsequent synchronizations. All robot attributes such as releases, supports, member types, loads, load combinations have to be preserved. The functional assumptions we made are: the link supports only advanced steel and robot 2016 versions. there is no support of older versions of these programs. The link design was based on the principle of making no changes in advanced steel, and only already existing functionalities of advanced steel were to be used. For advanced robot transfer direction, the link supports linear bar elements and gratings which are transferred as claddings for load distribution. For robot to advanced transfer direction, we support linear elements, internal forces, attributes such as supports or releases. The decision to use SMLX file format was based on the fact that this format had already been used for bidirectional advanced steel to Revit and plant to advanced steel data exchange. SMLX file is then converted to SMX file used for the link between robot and Revit to store robot analytical model information. This is how you can access the link. In advanced steel, both groups of buttons execute the same command, so there is no difference which group you actually use. The conversions of materials and profiles from a robot to advanced steel are based on the internal advanced steel mechanism developed for advanced steel data exchange with Revit, whereas for input from advanced steel to robot, robot extension mapping tool developed for robot to Revit link is used instead. In advanced steel, there are three available options. Export sends advanced steel model to SMLX file. Import opens a model from SMLX file. You should only use import when transferring your model from RSA to a new empty advanced steel project. Synchronization allows you to update and track model modifications made in robot using, after you select this option, the synchronization dialog displays a list of all modifications you made to the model during the recent transfer from advanced steel. You can select modifications you want to include in the synchronization and update your model with only these selected ones. List of changes which are about to be made can be saved before executing the synchronization process as a doc file. The link tries to match both materials and sections automatically, but also allows for manual mapping of these that cannot be automatically linked. A click on the indicated arrows expands the drop-down list and allows you to select both the section type and the section catalogs. In robot, you have also three available options. Export says robot model to SMLX file. Import is intended for the first transfer of a model, and synchronization allows to track and update a model with modifications made in advanced steel. After you select this option, the synchronization dialog is opened. It displays a list of all modifications made to your model in advanced steel, and you can select modifications you want to synchronize. The mapping of advanced steel profiles and materials in robot is similar to the link between Revit structure and robot, and it is also possible to match advanced steel profiles with created earlier RSA section labels. This slide shows the list of currently transferred object types and sections. I'd like to focus your attention on this particular feature of the link. User-defined welded I-shaped beams are tricky to map as they are built from plates in steel detailing programs rather than as a single shape as done in the structural ones. In Robot to Advanced Steel link, the mapping searches for predefined plates, flat bars in advanced steel, which match with sizes and flanges defined in Robot. Let me show how this is done. I created here in Robot the girder, user-defined one, and now we go to the integration option in Robot and we export robot model, and then we switch to advanced steel and export import tab, import the file that I created. Okay, and you can see if I select this transferred girder and go to Advanced Properties, I can see that the sections are actually two flat bars, two plates for web and flanges. And also at this stage, you may define welds connecting these plates. Okay, let me return to the presentation. The export with calculation results sends model with stored results from robot to SMLX file. In Advanced Steel, it automatically creates nodes in the transferred model. These nodes contain information about support, releases, values of internal forces from robot, which you can use to perform code checking of connections in Advanced Steel. The export current selection option becomes available when you selected export or transfer action and made a selection of a part of a model. This exports only selected elements to SMLX file. If analysis results are available for the selected elements, they can be also exported. If you mark structural elements only checkbox, these advanced elements that are selected, which have the structural members option marked, are exported. In Advanced Steel, this attribute is available in the Element Properties dialog on the Behavior tab. Create Advanced Models background becomes available when you selected Import or Synchronize from Advanced for transfer action. The background displays geometry of the Advanced Steel model from the recent transfer. It allows you to track differences in the model geometry between the original model as defined in Advanced Steel and changes you just made to it in Robot. The display of the background can be switched on and off in Robot in the way shown on this current slide. Let's have a look at fabrication and analytical models of the same structure. In Advanced Steel, important is shape and exact position of a profile with respect to other profiles. In Robot, important are section properties and model connectivity. 3D solid profile shape for Robot is only informative, therefore analytical model may not be exactly the same as the fabrication one when you switch display of section shapes in Robot. The analytical line display in Advanced Steel can be switched on and off in the way shown on this slide. Let me show you that the concept of the independent analytical and fabrication models are not unique to Robot and Advanced Steel Link, but exist in other programs too. As you know, it can be found in a Revit structure, but it also exists in Plant 3D. Okay, so let me show Plant. I will close this project and we'll open another one. And I will load the file. This is actually the part of this large plant that I presented on the previous model in Plant. And you can see that there is the option that allows you to display the structure in different modes. So, okay, this is shape mode. This is let's say how you see the structure in reality. You may name that fabrication model, whereas the line model corresponds to the analytical model as you are familiar with in Robot. You can see that these models can actually differ, and it may be necessary to correct the line model, analytical model, to have the correct results of the analysis in Robot. Okay, let me return to the presentation. Starting an analytical model in Advanced Steel or Plant, you should forget about the fabrication model principle and use the analytical ones instead. You will return to the fabrication model after you know the final sizes of your profiles. As you will get incorrect internal forces in elements due to support level, positions of beams with respect to their system lines as defined in Advanced Steel, cannot be simply modeled in robot as offsets. The geometry of a model as defined in advanced steel may need refinement to avoid very short calculation elements or lack of connections among bars of a structure. The exact geometry defined in advanced steel in many cases should be simplified for static analysis of a model to avoid unwanted secondary effects. In robot, there are many ways in which you can convert an important fabrication model into a coherent analytical one. I will demonstrate some of them in a few moments. If you use the link to determine the right sizes of beams and columns of your advanced steel or plant 3D model in robot, then I strongly recommend watching the recording of the third webinar that covers the steel design module of robot. The recording of this webinar is available on YouTube under the link shown on the currently displayed slide. There are few scenarios for use of the link. You may start definition of the geometry of a steel structure in Plant 3D and export it to robot for design, then send it from robot to advanced steel for final adjustment, and finally XREF or open the final advanced steel model back in plant with Object Enabler installed. So let's see how this can be done. Okay, I need to go to plant first. Okay, I will close this project and we open a new one, and then I will load the file. We have a steel structure supporting number of pipes. And first of all, I would like to focus your attention that this analytical model will need some adjustments. For example, this bracing are too short. But let me switch to symbol model so that you can see the real shapes of the elements. Okay, I will select one of the pipes, and if we go to properties, we can see that this is an 8 inches pipe defined with advanced steel object. What I'm going to do, I'm going to create a structural member. Okay, I will click on the origin of this pipe. I will finish at the end. Okay, I defined the I section, but if we select it and go to edit structure command, we can replace that with pipe of the size that corresponds to the real pipe defined in the plant. So for example, we will have a look at the 8 inches pipe. We can set the correct material. And now I can use the export to advanced steel. I will indicate the file name. I will select all the objects and I will export this structure. Okay, now I will start a new project in robot frame, and I will import the file. At the moment, there is a search for matching sections. The sections that are found are automatically matched. The ones that are not found, you can match manually. So we can open the American section database. We can have a look at pipes. We know that's 8 inches pipe. And then on the material list, okay, we may select the steel grade. And when we press the OK button, we will see the structure as defined in plant being transferred together with this pipe to robot. Okay, I mentioned that I may need to make some adjustments of the structural model. And seizing this opportunity, I will also like to introduce the couple of correction tools that we have got in robot. For example, extend. So we will select the elements that we want to use as the border lines, and we can simply click on these two short bracings to extend them to the beams and columns. Right? So this is the correction of the two short bracings. I somehow need to connect this pipe with the supporting structure. So what I'm going to do, I'm going to snap to perpendicular, and then when I select the node and I want to copy it, I can copy it to the beam below, and also now I can copy this node again to the pipe level. Now what I'm going to do, I'm going to define a rigid link connecting these two nodes, and finally I will select both the nodes and the rigid link. I will copy that 7 times so that I have the connection on each of the beams. I can define loads, self-weight, live load case. I mean, let's say that we will apply some load to the pipe, like the weight of the medium that is inside it. Finally, I need to apply the supports, so I can select the bottom nodes of my frame, for example, pin supports. And all I need is to calculate this model and show results. For example, we may have a look at the bending moment results caused by the pressure in the pipe. And now, of course, we can code check the elements, find the sections, and return with them to our plant or to advanced steel for detailing. Okay, let me return to my presentation. I will no longer need a plant, so I will close it. Okay. Another option to use the link is to start a model in advanced steel, then send it to robot, and finally update the original model in advanced steel. And let me show that on a couple of examples. So if I open plant, close this girder, I will load a model. Okay. So you can see these red lines. These red lines are actually analytical lines, analytical model representation in plant. So as you can see again, that will be a bit of corrections needed. So first I will export this model. I'll start a new project in robot. Import structural elements only. as a matching of the sections. And first of all, I would like to focus your attention that we have transfer of claddings. Transfer of gratings defined in advanced steel into claddings that you may use for load distribution. And of course, the model was selected on purpose so that you, to get you familiar with the other means of correcting the analytical model in robot. So this time, I'm going to use detailed correct option, and I will indicate the plane. Okay, so here we have some gaps between this plane and these short columns. I will specify the distance that matches the gap, and if I press the apply button, you can see that these elements are connected. I'm going to work in a similar way to get rid of these short cantilevers and connect the struts with the platforms. So I'm going to just indicate 3 points, and I will change the range so that it matches the distance. And you can see that short cantilevers are gone, and all I'll need to do is to move these 4 points to their correct locations. Okay, so I will move that. I need to select 4 of them. 1, 2, 3, and 4. Okay, 4 of them, and then just move them. And if I have a look at the other side, I may also make the correction to the line. So, okay, let me indicate the line. Okay, so the short cantilevers are no longer there. And also, I can double click on a node and move it to the right place. So, okay, we have the correct analytical model. What we need is definition of the supports. So I may again change the display of the model so that I can easily select the bottom nodes. I can select the pin support, apply them, and I will define again loads, self-weight, some live load. Okay, since I got claddings, I will use them for load definition. So, for example, -5 to all surfaces. Okay, and now I will calculate the model. And the reason is that I would like to show you how the load was transferred to the supporting elements. Of course, now we can go to the steel design module that I mentioned and change the size of the beams or columns so that they match the loads. Let's skip that. Instead, I will simply manually change one of the sections of the beam. I'll go to steel and I will select American W sections. And for example, well, I will use some large sections so that it is visible. Have I defined that? Oh yeah, it's okay. It's okay, so we have change in the section. So what I'm going to do, that represents the steel design process that we are not going to cover today. That was explained during the third webinar. So I'm going to send this modified model export. Okay, I will overwrite the SMLX file. Good. So I go back to Advanced Steel, and this time I'll synchronize. We'll see. I want to update my original model with the changes. And you can see there is a change in the beam. And I I apply the changes, and you will see that the model is updated, and of course we have got this large beam now visible in the advanced steel model. I would like to focus your attention that in the process we haven't destroyed already defined connections in the advanced steel. We haven't destroyed the locations of the elements, so the reference line remained as it was defined. So this is the main point of the link. Do not destroy what has been correctly defined or already corrected in either of the program. Okay, let me close this model and let me open another one. Sometimes you may have a large project in advanced steel, and you actually need only to focus on its part. So in that case, it is important to make sure that you select this part first, and it may be easier when you define these selection groups. You can then switch on or off the remaining part of the structure, and if you select the part that you want to design in robot, you may export only this part. Okay. We create a SMLX file, and now if I start a new project in robot, I can import these selected elements, add-ins, steel, import, and this time I will mark the background. Okay, I need to map, and actually I want to show you that you can map using the label. So for example, you may select one of the labels, user-defined sections, to match the profile defined in advanced steel. Right? So if we have a label, okay, for example, this is this predefined label. Of course, you may search through the database, but also for sections that are of non-standard shape, the label can be used. All right. So what I'm going to do, I'm going to show you for a moment in advanced steel the fact that this model has got a certain connections defined. And these connections include the gaps. So there is no common point for these elements. They are with gaps. But in robot, to, for example, use the steel connection module or to have a coherent results, we want to have all these elements to be actually snapped to a single position. So first, maybe I will just switch off the display of the background for a moment. I will also define the structural axis. Okay, let me click on Nodes, and then I will create Y-axis and Z-axis. Okay, I can press the apply button, and now I can use edit and detailed correct to structure axis and specify the distance, and when I press the apply button I can merge the node so that I have the correct analytical model. And let me now switch back the display of the background. And you can see that the background now represents the original positions of these elements as defined in advanced steel. So you can see what changes you made, and you may decide whether you want to move these elements in robot or you want to stay them as they were originally defined. Okay, let me export to advanced steel. And now, let me synchronize the model. As you can see, I keep the selection active, and this is very important. This is very important because if you don't, you actually delete the rest of the model. This is how advanced steel works. As you can see, there is no changes detected because the move of the elements that I made in robot are not deliberately not recognized as the change in advanced steel model. So if you want to move the element in robot and you want to have this change visible, you should delete this element in robot and enter that in a new location. Okay, so what I'm going to do now, I'm going to switch off the display, switch on the display of the entire structure, and I'm going to deselect that. And if I now run synchronize, okay, I will load the same file, you will see that all the elements that were not included in the selection will now be detected as deleted in robot. So there will be quite a list here, and if you apply these changes, you will simply delete the part of the model that was not selected. So it is important to keep the selection during the synchronization if you export it on the part of your advanced steel model. Okay, so let me close this, and I will open the last model that I prepared in advance. That's going to be this truss. So right, so I will export that. I will go to robot, start a new project again, import, and well, I would like to focus your attention that I have the structural elements only marked, and you will see that not entire model was transferred. Okay, you can see that I'm missing diagonals, but the gratings are transferred as claddings. So right. So I will start a new project, and this time I use the same file as previously, but I will import all elements defined in advance. Right. So we've got diagonals, but also we have railings and stuff that we don't really need. So if I go back to advance, I may select a couple of diagonals that were missing during the first import, and if I go to the properties, advanced properties, of course, on the behavior tab, I may mark the structural member checkbox, and this time, if I export the model, and in robot I import the same file, I mean the newly created file with diagonals being a structural part, structural elements only, I will have all these diagonals imported, but without elements that I don't want to see as analytical elements, as for example railings. So in this way you control which elements you want to have, which elements in advanced steel you treat as a structural. Okay, we have these diagonals imported. Okay, let me go back to the presentation. Well, you may also create a model in robot and send it or entire model in its part to advanced steel. This option is intended for production of fabrication drawings, but it also allows the structural engineer to send information about design forces for connections for which a fabricator is going to be responsible. Mind that for a group of connections created in advanced steel, you should name the connection with the largest forces as the master, because there is no code checking for forces imported from a model for slave connections. For example, for a secondary beam to main beam shear connections, make envelope of shear forces for selected group of elements in robot to determine the location of the master joint. Let me show how it works. So this time I will start my project in robot. I will open platform that I created. In this platform I already determined the sections and I've got the results. So we may, for example, see the diagrams for combination, right? Always see shear forces. So we have a set of the results. What I'm going to do, I'm going to export this model to advanced steel, but with calculation results. Okay, let's go to advanced steel. I will close this project. I will start a new one. And what I'm going to do, I'm going to import the robot model with the forces. And you can see we have these nodes marked with the flags. So if we select such nodes and we go to advanced joints properties, you can see first of all what kind of the support was defined in robot. It's pinned because all the rotations are free, and you can also see the results, I mean the forces, the reactions that were imported. And now if the design of the steel connection is the responsibility of the fabricator, he or she may use the connection module in advanced steel, for example, to create a pinned connection at the bottom of a column. So you can see that, okay, these forces can be used for the design. We focus on the design later on, and there is also the possibility to select either American or Eurocode. Well, if you want to create identical connections, there is the option in advance that allows you to create such a group, and you may select the master, join the best master connection, and click on others that you want to create identical connections. And as I mentioned, okay, if you go to the join properties for the slave connection, okay, it will be not possible to access the design. What you need to do, you need to upgrade that to master. And then in the join design, you can see that you have access to the results from robot. What is important is that when you have this group of connections, if you, for example, make a change to the master, all other slave connections follow. Okay, let me go back to the presentation. As the steel connection module in robot wasn't presented during the robot steel design webinar, I would like to quickly demonstrate how to use it. Let me show that on the example that I've got. So if we go back to robot, and for example, we select two beams, we can use this selection to create a connection. There are a couple of predefined connections in this file, but okay, how to create one? You click on this icon, and basically you, based on the selection, robot make a choice of the connection type, and then you may specify the parameters, and you may code check that for the defined combinations, and have the calculation node. Okay, let me go back to the presentation. As I mentioned at the beginning of the webinar, you can also use the link to design steel connection in advanced steel. And what I already presented, that there is a join design tab where you can select the forces from robot that you want to use for the design, and there is a report button which generates the calculation node in the HTML format. Well, this HTML node can be converted to RTF format, for example, for the connection types that are not available in robot, or when you want to code check the connections according to American code. And using Word and saving this as RTF or via clipboard, you can insert it into the documentation in robot. So how this is done? Okay, I will go to Advanced Steel, and I will select the main and secondary beam here. Okay, we have, well, I need to find the clip angle connection. Okay, so I select the main beam. I will select the secondary beam. All right, also the parameters that allows you to define the number of bolts, position of bolts, and in the vertical bolts tab I need to set middle to have the correct arrangement of bolts. And now if we go to join design, I can use the forces from robot, okay, to design the connections, this particular connection, and I can have the report. And now I can copy that to clipboard, and I can either copy that to Word or save as RTF format, or I can simply copy that to clipboard, and being in robot, I can go to printout composition, for example, that I will add the structure view, and then note after. I will paste this verification. I will save changes, and if we have a look at that, you can see that we have a structure view and the results from advanced steel in the robot calculation node. Okay, let me go back to the presentation. And in addition to the steel connection nodes, you may also add some other data from advanced steel model to robot printout composition. For example, it can be anchor bolt plan generated with use of a camera view. And how this works, if we go to advance, okay, we close this connection, I can define, maybe I will open another model with connections that I defined. Okay, for example, I predefined a model where I defined all the connections, and including the connections to the foundations, which I would like to focus on. And if I set a camera at the origin of the coordinate system, and I said this is going to be camera from anchor plan with certain distance from the definition level, I can go to design process, drawing process, and in this drawing process I can run the generation of drawing for cameras. Okay, for example, okay, and if I go to properties, okay, mistake. Drawing process, all cameras. Oh, all cameras. Okay, this one I need to use. And then if I go to, okay, if I go to the properties of the camera, I can go to the details and I can see the arrangement of anchor bolts, which I can change the scale for to match with my paper size. Right, and now I can move it to the middle of the paper. Okay, let me go back to my presentation again. Finally, I'd like to focus your attention on some tips. Most important, be careful when you work with selections, as you may easily erase part of your advanced steel model that I demonstrated. As you remember, the key assumption of the link was not to destroy already fine-tuned models during the synchronization. This is why moving imported from advanced steel elements in robot will not change the position of these elements in advanced steel during the synchronization, and that was this truss connection that I demonstrated. And in the same way, if you don't mark moving of advanced steel elements as a change that should be synchronized during robot model update from advanced steel, the already corrected advanced steel analytical model will not be changed. I will show what I mean. Okay, I will open this truss model in robot. I will export that to advanced steel. I will close these models and we'll start a new project in Advanced Steel. Okay, I will import the truss that I created in Robot. Okay, I will change the view. And now, okay, let's say that I need to change the profile of this pipe. I need to have it a bit thicker walls. And I also need to put my plate, move it slightly. Or maybe I will move it more so that it is visible. And now I will export that to SMLX file. And if I go back to Robot, I will try to synchronize. And I will mark this background. Okay? So by default, the change in the position is not marked. It's only the change in the section. So I will synchronize the model. Okay. And I will switch off the display of the sections. And you can see, maybe I will set the front, that this is the background line that corresponds to the position of this diagonal as moved in Advanced Steel. Now I can decide whether to move it or not. I may select that and I may want to move it. But let's say this change is tiny and I do not want to correct this model again. So that's why the position is not marked by default in Advanced Steel, but the background allows you to see what was changed, what kind of the change, what in the position was made in Advanced Steel. So right, let me go back to my presentation. Finally, just to remind you what I've already demonstrated, in Advanced Steel you can design separate connections or group them indicated in the master one. The change done for the master connection will be automatically replicated in all other connections from the group. Mind that the slave connections from this group are not editable till the moment you exclude them from the group, and verification can only be run for forces from a master joint. And just mind that the selection of profiles you decided on during mapping is stored in the database and automatically used by Advanced Steel full select projects. It is recommended to make a copy of the default database in case you need to restore the defaults. Seizing the opportunity, as always, I'd like to introduce you to Autodesk Knowledge Network site, where you can find useful articles on the topics covered during this webinar, as well as on many others. And now I would like to encourage you to ask questions using GoToMeeting tab.
Thank you, Arthur, for a nice presentation. Now we are waiting for your questions in question panel in webinar window.
So, okay, I understand that we're running short of time at the moment, so please feel free to post any question or comments on our forum or Advanced Steel forum, and we'll try to handle them. And I would like to thank you for attending this webinar, and I would like to invite you to join us for the next one on vibrational force and footfall analysis. Thank you very much.